So hey guys, welcome back. In this video we are gonna be looking at some of the questions for exponentials, and then we'll try to solve them or simplify them as far as we can without using a calculator. So in the previous videos we looked at what exponentials are and what the different um, the exponentials means, and if you have a rational exponential or a negative exponential and the ideas behind it. But now it would be a good idea to see them put into practice, because in mathematics you can't really learn anything unless you learn it by example. So anyhow, so jumping straight to it, we'll start off with the very first question. So it's minus 10 to the power of 3, right? So what it essentially means is that using the same uh, basics that we have looked at, so your minus 10, that is your base, and 3 is your exponent. So it essentially just means that you need to multiply minus 10 with itself 3 times. So we have the first time, the second time, and the third time. And just remember that every time you have this minus in the very beginning, you need to multiply it as well. A lot of people, they actually forget the negative, but it's actually very important for you to keep that negative when you are writing out the exponential. So now since it's to the power of 3, so it's 10 times 10 times 10. So let's just take, that's 100, then 100 times 0, that would be 1,000. A negative times a negative, that's a positive. So we can actually just write it on right here. So that is a positive. And then a positive times a negative, well, that's a negative. So the answer is going to be a negative 1,000. So that essentially is the very first problem, a very simple one. Just a negative 10 to the power of 3, that would give you a negative 1,000. And if you would like to learn more about the effect of the exponentials on negative bases, then do remember to check out our previous video where we had a look at much more other complex examples. Anyhow, so moving forward. So the next one is 2 to the power of 0 plus 2 to the power of 5. So we saw in our previous video that if a base has been raised to a power of 0, then it is automatically 1. And that is very important because it's not just equal to 0, but it's equal to 1. That means that we can rewrite this as 1 plus 2 to the power of 5. And then 2 to the power of 5 is similar to the one above. So that means that 2 being multiplied by itself 5 times. Now don't do this in your head when you can just write things down. So 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Then that means that it will be 1 plus 32. And then you get the answer, which is 33. Voila. So 2 times 2 to the power of 0 plus 2 to the power of 5, it can be solved using this method right here. Coming up to this example here. So now you have a very ugly looking number in the brackets, but luckily for us, it's being raised to the power of 0. So it means that it is equal to 1. And you're done. Coming to the next one. So now you see we have a negative exponential and we have a positive exponential. A negative exponential, as we have looked before, means that you need to rewrite this like this: 3 to the power of a 4 plus 3 to the power of a 4. And then I'll write it right here. And now since we need to simplify this, you need to be able to write it into one fraction. Of course, we can also simplify this using a calculator, but if you were to simplify it without a calculator and being able to write it as one fraction, then what you do is you make a line and you write 3 to the power of a 4, because you know that this is equal to 1. So if I multiply them together, I get the base, the common denominator. That is 3 to the power of 4. Then since you have a 1 there, so we are not changing that, plus, but now this was 1. So we need to multiply this with 3 to the power of a 4. And if you are not if you're not clear on how we are moving ahead with this, then do remember to check out our other video where we have a specific look at how to simplify the fractions. Anyhow, but now we need to, now using the index laws that we have looked at before, 3 to the power 4 times by 3 to the power 4 can be rewritten as 3 to the power of 8, and then we just divide it by 2 to the power 4. There. And now the exponential, the index rule that I'm using here is something that says this. So a times x times by a times y is actually equal to a times to the power of a to the power of x plus y. As long as the bases are the same, then we can add the exponentials together. So 3 to the power 4 times by 3 to the power 4, that means that it's 3 to the power of 8. And if you put this into the calculator, you will get something that is equal to around 81. But there is no way for you to be able to solve that without calculating all the individual terms, which we can also do, but why would you do that? Because you can just simplify it using the fraction that we have done so here, and then you can be done with it. So moving ahead, let's take another example. So now you have 16 divided by 2 to the power of 3. Now, when you look at an question like this, of course, it would be very natural for you to think that there is no way for you to simplify it because there are no exponentials on the numerator. So you only have an exponential in the denominator. Depending on what sort of question or the sort of exam you're sitting in, you could go either way. You could either expand the denominator into an actual number. So for example, what, maybe just we can do that. In the first method is that 2, and now 2 times 2 is 4, 4 times 2 is 8, so you get 16 divided by 8, and we know that 8 ones are 8 2s are 16, so you actually get an answer that is 2. That's one way to do it. But another way to do it using exponentials would be that you convert the above number into an exponent. So can we rewrite 16 as an exponent? Let's try it out. What you do is you say, what two numbers can you multiply together using the number 2? That means that you can actually write it as 2 times by 8, right? Can you further divide 8? Yes, we can. So 2 times 4 is 8. And then we can further divide 4. So that means that 1, 2, 3, and 4. I'm going back down. But that means that 2 to the power of 4 is equal to 16. Then we come back to this fraction, and let's rewrite the above numerator as 2 to the power of 4 divided by 2 to the power of 3. And as per the index laws, if we have two exponentials that are being divided with each other and they have the same base, then we can subtract the exponentials. So it will be 2 to the power of 4 minus 3. That means that it will be 2 to the power of 1. And we know that if something is raised to the power of 1, then you just get the base as the answer. There. So either way, whatever method you choose to employ, you will get the exact same answer. We got a 2 here and we got a 2 there. In this case, luckily for us, it was 2 to the power of 3, so it was very easy for us to calculate. But imagine if instead of 8, it had been 12, then it would not have been possible for you to use the first method. Then you would be forced to use 2 to the power of 4 divided by 2 to the power of 12, and then 4 minus 12, that would be minus 8, then it would be 1 over 2 to the power of 8. So therefore it's always a good idea to identify whether you can convert a number into an exponential, and the exponential that you're converting it into has to match with the base of the other exponent that you are trying to figure it out with. Like in this case it's 16, and you saw that we start by 2 because 2 is the number that we want to convert it into. So 2 times 8, then we can convert 8 into 2 times 4, and then we can finally convert 4 into 2 times 2. So it's not very complicated if you try to do it in a very structured manner. But luckily we got a confirmation as well that you get the exact same answer either way. Moving forward. So now you have 27 to the power of 1/3. And as we have seen earlier in our other examples, that what it means is that you need a cube root of 27. What this means that you need a number when multiplied by itself 3 times gives you the number 27. So it will be, we'll start from the very scratch. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 2 times 2 is 4. 4 twos are 8. 3 times 3 times 3. 3 times 3 is 9. 9 threes are 27. Voila. So that means that if 3 raised to the power of a 3 gives you 27, then the answer to this cube root is 3 to the power of 3. Moving forward, interestingly enough, so now we have 27 raised to the power of 2/3. In this example, we had 1/3, so therefore we took the cube root, but now we have 2/3. So let's put it this way. So you have 2 to the power of 7, and what this means is that you need to find the cube root, and then you need to raise it to the power of a 2. Oh, and sorry, the answer is not 3 to the power of 3, it's actually just 3. Yep, sorry, it was my mistake. The answer is just 3, not 3 to the power of 3. I just wrote that to show you that it was being raised to the power of 3 to get you 27, but the answer is the base, not the actual exponential expression. So we have already solved the cube root of 27. We know that it is 3, but now we need to raise it to the power of a 2 because we have 2/3. So we know that 3 times 3 is 9. There we go. So essentially that is the difference between 27 being raised to 2/3 or 27 being raised to 1/3. And then finally, so we have this last example for this video. So now we have 3 numbers that are being multiplied with each other, and we don't have an exponent to go with them. For the first one, now we can have a look at what are the exponentials that we can possibly convert these numbers into. The first expression is that you have 16, you have 4, and you have 24. 4 times 4 is what? 16. That's correct. That means that 4 squared is equal to 16 times by 4. And then 24. What two numbers that we can multiply together gives you a 4? 24, I believe 4 times 6. So 4 multiplied by 6. Can we break 6 down into 4? No, we cannot. So we get 4 squared times by 4 times by 4 times by 6. Let's break it down into one big exponential. So 4, we know that the base are the same. That means that we can add the exponentials. We know that this is 1 and 1. So 2, 3, 4. So we can rewrite this as 4 times 4 times by 6. Now we can't possibly stop here because we have converted this into an exponential, but is this the most basic exponential that you can have? No, right? Because you can further break this down, because we know that 4 is actually can be broken down into 2 squared, because 2 times 2 is 4, and 6 can be even further broken down into saying 3 times 2. So let's do that. Let's rewrite 4 is 2 to the power of a 2, and then do not forget that we had a 4 as an exponential, so the 4 stays right there. Then you have 2, and then you have 3. And now the reason I did it in this way, because I wanted to show you this example as well, that if you have an exponential that is raised on another exponential, then as per the index laws, you can multiply the exponents together. So basically this would then be 2 to the power of 8 times by 2 times by 3. Now you have, again, the bases, they are the same. So 2 to the power of 8 times by 2 to the power of 1, and then you just get 2 to the power of 9 times by 3. There. Now, of course, essentially we could have just directly done it in the very beginning as well. Like if you were to not take all the steps with the 4s, you could have done 2 to the power of 4 times by 2 squared times by 24. 2 times 12, that is 24, right? But 12 can be further divided down into 2 times 6, and then 6 can be further divided into 3 times 2. Let's confirm. 2 times 2 is 4. 4 twos are 8. I think we made a mistake here, right? So 2 times 2 is 4. 4 twos are 8. And 8 threes are 24. So it matches. So now how many 2's do we have? 1, 2, 3, 4, 5. 4, and then we look at the exponentials. So 4, we add them together. So 4, 5, 6, 7, 8, 9. 2 to the power of a 9 times by 3. You get the exact same, right? So of course you can either break it down into 4's first and then break the 4 into 2, or you could just directly break it down into the 2's from the very beginning. Either way, you reach the final conclusion or the same answer in both cases. So that was all for today. That was all for this video. And if you liked it, then do remember to like and subscribe to Epsolot channel for more videos. And of course, also stay tuned for our next video where we're going to have a look at more examples, specifically on the index laws and how they can be applied in practice. Thank you and have a great day, everyone.